Hello, in this video we will introduce a new lineup of high-performance signal sources, the 96XX series of DDS generators. The DDS, which is short for Direct Digital Synthesis, is a powerful technique that allows the generation of high-purity multitone signals. With ultra-fast switching between output frequencies, fine frequency resolution, and operating over a broad range of frequencies, these new products make an agile signal source that's suited for demanding applications in a number of industries like biomedical test equipment, imaging systems, communication, semiconductor testing, or quantum research. Fully programmable, the products are available in 3 different form factors, as PCIe cards, PXIe modules, or LXI Ethernet netbox systems. The cards and modules offer up to 4 channels, while the standalone LXI units can provide from 2 to 24 channels. For the cards and modules, up to 50 sine waves, or cores or carriers, are available on a single output channel. For applications needing more than 50 tones, the larger netbox units support up to 300, or it's possible to connect multiple cards together with a StarHub synchronization module to create systems with up to 400 tones. All the 96XX series DDS generators are designed for producing low noise, variable frequencies with excellent spurious performance, up to 200 MHz in bandwidth. Each channel incorporates its own 16-bit digital to analog converter that is clocked at a rate of 625 megasamples per second. Front-end signal conditioning allows programmable amplitudes up to plus or minus 2.5 volt into 50 ohm loads, or plus or minus 5 volt for high impedance. DDS makes producing sine waves simple and efficient. Let's look at an example. For one endless sine wave, just 2 commands are necessary in your programming. Here we have programmed an amplitude of 90% and a frequency of 100 MHz. The results can be seen on the scope. Looking at the spectrum analyzer, the frequency of the sine wave is shown with low jitter, low distortion, and low spurs. Programming can be done through different programming languages like C, C++, C#, Java, Python, LabVIEW, or MATLAB, with Python offering a new high-level API for easy access to the DDS. Let's look at a multi-carrier example. Up to 50 sine waves can be superimposed on a single output channel. In this example, we're generating 32 sine waves on one output. They all have 3% amplitude, and the frequencies go from 60 MHz onwards in steps of 4 MHz, leading to frequencies of 64, 68, 72, and so on. The scope shows the resulting waveform of the 32 superimposed sine waves. The spectrum analyzer shows the 32 frequencies. Changing the DDS settings is simple. You can upload all the settings like frequency, amplitude, and phase during runtime or via preloaded sequences of DDS commands. The settings changes can be triggered externally or by internal timer or immediately on command. No transition jitter or glitches appear, and the timing resolution for commands is as small as 6.4 nanoseconds. DDS commands can be structured to occur sequentially, one after each other. As the units have gigabytes of onboard memory, there is no problem to preload millions of commands if you like. It is also possible to program linear changes of frequencies or amplitudes with only one simple command. Here is an example. We will shift the frequency for one of the carriers by 100 MHz, from 20 to 120 MHz within 10 seconds. Just set the duration to 10 seconds and the slope speed to 10 MHz per second. All commands, like lowering the amplitude in the green block, can be pushed into the FIFO queue at any time, right before the next trigger event. With the DDS generators, very complex frequency constellations can be created using high-speed streaming and frequency multiplexing. This is needed for quantum computing and driving of AOMs and AODs. Here, 50 sine wave carriers are frequency shifted to guide laser beams used for catching and holding the atoms inside a quantum computer and allow the atoms to perform the calculation process. Other applications can be found in communication systems where fast adaptive changes for frequency or phase are required. Need to generate more complex waveforms? Then simply load the 96XX AWG firmware option and convert the DDS generator into a fully functional arbitrary waveform generator, AWG. In AWG mode, you can replay arbitrary waveforms on all active channels synchronously. To switch back to DDS mode, just reload the DDS firmware whenever you wish.